Let x1 so on xn be the random sample from a normal distribution with the mean mu and variance sigma square. Define mean x bar is equal to 1 upon n sigma I varying from 1 to n xi, and s square is equal to 1 upon n sigma I varying from 1 to n xi minus x bar square. Show that a x bar and s square are independently distributed, and b n s square upon sigma square follow the chi-square distribution with n degrees of freedom. Now proof A. First we take up the problem for the distribution of s square, the variance of a random sample x1, x2, xn from the distribution of n is equal to mu and sigma square. Let us first consider the joint probability distribution of y1 is equal to x bar, y2 is equal to x minus x bar, y3 is equal to x3 minus x bar, so on, yn is equal to xn minus x bar. This is equation 1. The corresponding inverse transformation x1 equal to y1 minus y2 so minus y3 so on, yn x2 equal to y1 plus y2, x3 equal to y1 plus y3 so on, xn equal to y1 plus yn. This is equation 2. Has equivalent n since sigma I varying from 1 to n xi minus mu whole square is equal to sigma 1 to n xi minus x bar plus x bar minus mu bracket close whole square is equal to sigma 1 to n xi minus x bar whole square plus n xi minus x bar minus mu whole square. Since 2 x bar minus mu sigma 1 to n xi minus x bar is equal to 0, therefore the joint probability density function of x1, x2 and so on xn, then bracket starts 1 upon square root of 2 pi bracket close whole raised to power n exponential square bracket starts sigma xi minus x bar whole square upon 2 sigma square minus n x bar minus mu whole square upon n2 and 2 sigma square, where x is equal to x1 plus x2 and so on xn, and this is equation 4. Minus infinity less than xi is less than infinity I varying from 1 to n, thus with the y1 is equal to x bar and x1 minus x bar equal to y2 minus y3 so on yn, then joint probability density function of y1, y2, yn is n 1 upon sigma square root of 2n bracket close raised to power n exponentials minus y2 minus y2 minus y3 so on yn whole square upon 2 sigma square minus sigma 2 raised to power n y1 square upon 2 sigma square minus n bracket starts y1 minus mu square bracket close whole square upon 2 sigma square bracket close minus infinity minus y1 minus infinity where I varying from 1 to so on, and equation 5. Now 5 is the product of the probability density function of y1 and namely 1 upon square root of 2 pi sigma square n exponentials minus y1 minus mu whole square upon 2 sigma square upon n square bracket close minus infinity is less than y1 is less than plus infinity, and the function of y2 y3 and so on yn. Therefore y1 must be independent of n minus 1 random variable y2 y3 and yn, and the function of y2 y3 and yn is the joint probability density function of y1 y2 and yn. This implies that y1 is equal to x1, thus n bracket starts y1 minus mu square upon sigma square is equal to n x bar minus mu whole square is upon sigma square is equal to w1. This equation 6 are independent of y2 minus so on minus yn whole square upon sigma square plus sigma 2 to n yi square is equal to 1 to n sigma 1 to n xi minus x bar whole square upon sigma square is equal to w2. Hence the result. B part, we are to prove that nx square upon sigma square minus chi square is equal to n minus 1. Now I varying from 1 to n x sigma I varying from 1 to n xi mu square sigma I varying from 1 to n xi minus x bar plus x bar minus mu whole square is equal to sigma I varying from 1 to n xi minus x bar whole square plus 2x bar minus mu into sigma I varying from 1 to n xi minus x bar plus sigma I varying from 1 to xi minus x bar minus mu whole square sigma I varying from 1 to n xi minus x bar square plus n into xi x bar minus mu whole square. Since sigma I varying from 1 to n xi minus x bar is 0, dividing throughout by sigma square, we have sigma I varying from 1 to n xi minus mu upon sigma square is equal to sigma I varying from 1 to n xi minus x bar whole square upon sigma square plus x bar minus mu upon sigma upon square root n is equal to sigma I varying from 1 to n xi minus mu upon sigma square is equal to sigma I varying from 1 to n xi minus mu upon 6 square upon sigma I varying from 1 to n xi minus x bar square upon sigma square x bar minus mu upon sigma and sigma into square root n whole square is equal to sigma I varying from 1 to n xi minus mu upon sigma square equals to n upon sigma square sigma I varying from 1 to n xi minus x bar square upon n plus x bar minus mu upon sigma square root n upon square root n whole square is equal to sigma I varying from 1 to n xi sigma xi minus mu upon sigma square and sigma I varying from xi minus mu upon sigma square and square upon sigma square plus xi minus upon sigma into square root I mean whole square is equation 7. Since s square and sigma square are independent, so now writing the moment generating function for equations 1 minus 2t raised to power minus n upon 2 is equal to m n square upon sigma square t 1 minus 2t minus raised to power minus 1 upon 2. Since xi minus mu upon sigma square is congruent to chi square n, so xi minus mu upon sigma into square root n whole square is congruent to x square 1 m n square upon sigma square t is equal to 1 minus 2t minus n minus 1 upon 2, which shows that n square upon sigma square is congruent to chi square n minus 1, hence the result